a just as a sort of warning to everyone to start out. Oh, sorry. This is going to be a talk about history and philosophy of category theory, so it's not a category theory talk as such. So I hope that it won't scare everyone away. So I'm going to be talking about a sort of a puzzle, I guess, in the history of category theory. So William Lawvere has written several papers discussing the German philosopher Hegel in depth. So I've given a list here of a couple of those texts. There are also some references to Hegel in some of the other texts that he has written or co-written. I'm not going to talk about those two in my talk today. But Hegel, in general, has very little to say about mathematics, and there are very few mathematicians who describe themselves as being inspired by Hegel or who quote Hegel. And so what I'm interested in is why Lawvere is the exception to this rule. And in the literature on the history of category theory, there's generally not a lot to say about Lawvere's interest in Hegel. So I just took a quote here from Ralph Krömer's book on history of category theory. He just says, I do not comment on Lawvere's Hegelianism. And we'll see a little bit later that that's not an entirely accurate way of describing Lawvere's relationship to Hegel. But in general, there doesn't seem to be a lot of interest in examining this problem. So just a quick introduction of who Hegel was, because he's likely not that familiar to a mathematical audience. So he is generally regarded as a philosopher belonging to the German idealist school. He wrote in the early 19th century. So I've given some of his publications here, and the one I'll be focusing on is the second one on this list, the Science of Logic from 1812 to 1816. And he also, several of his lecture courses were published posthumously, but you'll note that there is no lecture course on philosophy of mathematics here, so that there's no sort of sustained interest in mathematics on his part. So I'm going to focus, as I said, on Hegel's logical works. So the Science of Logic, the 1812 to 1816 text, is about a 700-page book of extremely dense conceptual derivation. So I can't really give a full sort of picture of that book here, but one way of looking at it, or one way of understanding what Hegel does in that book, is to see the logic as a sort of philosophical semantics. So it's an investigation of thinkable contents. What sorts of thoughts can someone have if they have access to certain types of concepts? That book was published in two parts. So the first part is called the Objective Logic. That's the one that the title page of is displayed here, published in 1812. And the Objective Logic goes through a series of some of the traditional categories of metaphysics, so beginning with the concept of being. And then the Subjective Logic was published in 1816. And this is an exposition of some of the traditional topics of logic, like the concept, the judgment, and the inference. And then in both parts of the book, Hegel uses a method that he calls a dialectical method. So what exactly that means is a sort of a debated point in scholarship on Hegel, but one way of understanding it would be that each concept in the set of concepts throughout the book is made to develop in such a way that it leads to an internal contradiction. And then that contradiction is overcome by introducing a richer, or as Hegel calls it, a more concrete concept. So this is sort of the general picture of the method of the book. And then I'll just note sort of in passing that the science of logic also contains Hegel's most extensive discussion of mathematics. There are two long remarks on the interpretation of calculus, but these passages are precisely ones that Lawvere does not talk about. So it's not Hegel's discussion of mathematics in this text that he's interested in. So I'll start with going through some of Lawvere's texts where he talks about Hegel. So starting with the 1989 text, Display of Graphics, and probably my favorite title of a mathematical paper ever because of the mention of the taco at the end. So he starts his paper by proposing to mathematicize the Hegelian method, and so the purpose is for the organization of any branch of knowledge. So he suggests here in this passage I quoted that the Hegelian method can be mathematized. It's not inconsistent or too fluid to be mathematized, and this mathematization of the Hegelian method would be beneficial to the project of organizing any branch of knowledge. And then Lawvere also refers to Hermann Grassmann, the 19th century linguist and mathematician, as being a practitioner of the dialectical method that he's calling for. And so he's referring here to Grassmann's text, the Ausdehnungslehre, in the two separate editions. And this is recognized as a sort of precursor of modern linear algebra. But that he developed some of the concepts of space and geometry from sort of first principles in that text. So I think that's what Lawvere is thinking of there. And then he also introduces a categorial definition of the Hegelian concept of the unity and identity of opposites. So I won't go through that in any detail here, but he does try to take this concept from Hegel's science of logic that might seem sort of hard to grasp or hard to analyze, and he tries to give a definition of this concept in terms of category theory. And here is the taco of the title. I won't get into the meaning of this diagram, but I couldn't resist the temptation to share that. And then there's an important endnote in the text that clarifies Lawvere's relationship to Hegel. And this is what I meant at the beginning when I said that calling Lawvere a Hegelian is not exactly accurate. So he explicitly states here, I am not a Hegelian. And what he objects to is the idealism of Hegel. So the fact that Hegel's logic leads up to this sort of unifying concept of the idea, and what Lawvere is interested in is primarily the first part of the logic, the object of logic, and so he takes it that that category theory as a discipline of mathematics has been in effect realizing the program of objective logic that Hegel had set out, and he mentions here. So a couple points that I also wanted to mention in this passage that I quoted. So he mentions that his interest in the science of logic came about because of some discoveries in the foundations of homotopy theory. And so this is a question that maybe someone in the audience can help me with, but I was wondering exactly which discoveries he might have in mind and why that would lead him to Hegel. And then another point that I'll mention is that Lawvere also uses this phrase, the rational kernel of the Hegelian method, and this is an allusion to Marx, who uses this phrase in the 1873 afterword to the second German edition of Capital, and so he uses this phrase in calling for a separation between Hegel's dialectical method and his idealistic philosophy as a whole. So moving on to the next Lawvere text, so the categories of space and quantity from 1992. So he again refers to Grassmann, and he has a extremely sharp criticism of what he calls bourgeois philosophy that denies the possibility of knowledge and emphasizes unknowability in mathematics. And he makes reference here to Lenin's 1909 text, Materialism and Imperial Criticism. So again, that's not a reference that many mathematicians will make in their texts. So that's another line I want to investigate. But he again identifies category theory with this concept of objective logic from Hegel, and he calls for a close collaboration of philosophers and mathematicians. So he argues that the philosophical distinctions between concepts like general and particular, objective and subjective, being and becoming, etc., that these can be made precise by introducing mathematical models, and in particular category theory models for these oppositions of concepts. And then he introduces this opposition between space and quantity as two philosophical categories, and he gives definitions in mathematical terms, in terms of mathematical categories, of space and quantity as being distributive and linear categories, respectively. So distributive categories are ones in which there are products and co-products that distribute over each other. And then linear categories are categories in which products and co-products coincide. And so he argues that these two definitions allow us to capture the general opposition between a space and a quantity, and to reason about that opposition in precise terms. And then space and quantity, of course, interact with each other. So we can have quantities that vary over spaces, and we can also form spaces of quantities. And those varying quantities can be either extensive or intensive. And these are, again, categories that Hegel studies in the science of logic. And Lawvere gives categorial definitions of these terms as well. And then finally, spaces serve as the setting for becoming. And this is, again, another key Hegelian category. So within a space, you can have a process of becoming where a point is mapped to another point. And again, there's more development of this concept of the unity and identity of opposites that Lawvere is drawing from Hegel. And so he proposes that we can understand this concept as developing a kind of structure, ascending structure, which is similar to the structure of the science of logic. So each level is reflected in a higher level. And then he uses Hegel's term Aufhebung, so that's the sort of overcoming of one concept by the next that I mentioned at the beginning. He identifies this with a jump from one qualitatively lower level to the unique next higher level. And he again points to the need for collaboration between philosophers and mathematicians. So this is a sort of recurring theme in these texts. And then the last text that I wanted to mention here is the tools for the advancement of objective logic. So he gives this somewhat difficult pronouncement about category theory. So he says that category theory has approximated a particular model of the general, sufficient as a foundation for a general account of all particulars. And he gives us this diagram of the relationship between the objective and subjective within the relationship between being and thinking. So within thinking, we can think, we have the subjective realm and the objective realm, what we're thinking about. and that whole process, that relationship between objective and subjective, is itself something that exists, so is within the realm of being. And so there's this sort of complicated interaction between these different parts of this network. And this diagram, I believe, also appears within sets for mathematics. And then he also goes into this categorial exposition of what he calls the concrete general. The more usual translation of that term is concrete universal. So this is, again, a Hegelian term. And so he gives this explanation of how we can start from something abstract, an abstract concept of the essence of a particular domain of thought, and then we can form what he calls the concrete general, which is the category that captures all the transformations that occur within that abstract domain of thought. And so this is a concrete general in Lavere's terms. Right, and so I promised in my abstract to give some indications of what I take is a dialectical way of practicing mathematics drawn from these texts. And I sort of want to qualify these statements here by saying that I'm certainly not telling anyone how they should practice mathematics, but I wanted to point to a way that Lawvere seems to have tried to practice mathematics in these texts. And I would also say that it's quite possible that you are practicing dialectical mathematics without even knowing it, and if these qualities are what makes someone a dialectical mathematician. So some of the qualities that I took from those texts are collaboration between mathematicians and philosophers. Working together with philosophers and trying to analyze philosophical texts is part of what makes a dialectical mathematician. Translating philosophical concepts into mathematical constructions and vice versa. So there's another passage that I didn't mention here where Lawvere suggests that the development of category theory involved a sort of mathematicians having to generate their own philosophical concepts because he thinks that the philosophical world was not sort of providing those concepts for them. And then the last quality that I sort of identified here is that dialectical mathematics treats mathematics as a means of studying the interaction of concepts. So starting from pairs of concepts like being and becoming, or the general and the particular, it tries to develop precise mathematical models for the interaction of those concepts. So these are just some suggestions of some of the qualities of dialectical mathematics that I think are exemplified in Lawvere's texts. Thank you.
All right, do we have any questions? Okay, Dennis, you can unmute yourself and ask the question.
So I wanted to ask what exactly, so you mentioned Hegel's objective logic sort of thing, and I was wondering if you could explain like what exactly Hegel says about objective logic, or what that means a little bit. I don't know, I might have missed it from your talk.
Right, yes, thank you. Thank you, that's a very good question. So the way that the division between the two parts of the science of logic is sort of set out is that the first part goes through some of the traditional concepts of metaphysics, so being, essence, cause and effect, and so on, and it shows how each of these concepts leads to a contradiction. So by using this concept in a sort of one-sided way, as he puts it, so trying to isolate this concept and apply it to something in that way leads to a contradiction. And the only way to sort of overcome this contradiction is to introduce a new concept, which is richer and as he puts it, more concrete. And so it is a concept that has more determinations in it, so it has more structure to it, and by passing to successively more structured concepts, you have a more and more adequate way of grasping real entities in the world.
Okay, yeah, thanks.
Any other questions? Adrian?
Yeah, thanks firstly for the talk. It was really interesting. I'm keen to explore and to find out about kind of these kinds of collaborations between mathematicians and philosophers. One of the things I think has been difficult with that is that in mathematics we like to make things precise to be able to prove things about stuff, whereas by the time you do that, it seems like you've kind of lost the philosophers or the philosophy kind of motivation behind the concepts, because you pin something down too much so that it's too restrictive. I was wondering if you know of examples where there's been kind of productive collaboration between mathematicians and philosophers that hasn't kind of run into these problems or has overcome these problems in interesting ways. Thanks.
Right. Yeah, that's another good question, and it's especially relevant because that sort of problem is precisely one that Hegel identified in he gives his sort of understanding of what a proof is based on he thinks that mathematical proof is inadequate for conceptual purposes for reasons like the ones that you identified. So there's a mathematical proof sort of pins down concepts in a way that is insufficient for conceptual analysis, and some examples of this